Claim 3 months of Discord Nitro for free. What's Discord Nitro? What is Discord Nitro?
It's for Discord. Premium subscription.
What does that do?
Larger file size.
Okay, so now first part. Let's talk about first part. The first part is the integration between the 0 to 300. Okay, so people like Ian, make sure you write down this part. Make sure you write down integration 0 to 300 R of t dt equal to 270. You cannot just write down 270 and you think life is gonna be fine. No, you have to write down what the instruction to what the rubrics were, because they basically rubric says the integral and the answer. If you just have answer, they don't even count both points. Okay, so you must write down this, and also that's easy to earn points. Got it? Yes.
For like the answer, right? Say you wrote 270 people from like 0 to 300. Does that give you the same points, or do you have to write the sentence out? Like how they have.
I mean, you don't have to look. Math people don't like to read. Me, I hate reading. You say just 207 people enter the line and the escalator. Do you really need a domain there? Probably not. You just say at end of 300 seconds, it's like that. That's it. That's pretty much it. They don't need to read. Probably like the only thing that I will probably read is like integration 0 to 300 R T dt equal to 270, and just write a simple sentence. You don't need like a complex sentence, doesn't even need like transitions. So for B, they said, well, what happened at end of 300 seconds? Well, think about this. There was a water bottle, and think about this water bottle is leaking, and that's the rate out. So if I stick a hole right here, right? So if I stick a hole here, I will have leaking out, and there is thing that can pump in. I can adjust different rate when I pump in. So those are the things that you have to think, and how much water you already have inside the water bottle. So so let's start at 300 seconds. 300 seconds, not just say if I have like maybe like half liter here, and I have things that comes in and I have things goes out. That basically just whatever's inside already, adding onto whatever comes in and subtracted the whatever goes out. And when you do that, it'll be 20, whatever is in there, plus the integration between 0 to 300. RT is the things that comes in, minus 0.7. Now, a lot of time people thought is 0.7t. I think the most common mistake is people put 0.7t rather than 0.7.
Because we're already finding the time, so the 0.7 only applies once because we're finding the time of that, so the 0.7 keeps applying throughout all the time.
Yes, because if you integrate it, it will be 0.7t, right? Is that a guys looking for me?
What?
What did you want? Oh, there now? Oh, okay. Don't worry about Ian. Don't worry about Ian. Ian, let it go. Let it go. She's I didn't see her. So that's gonna be 80, and when you integrate this, you're gonna get this. Now, this one's kind of confusing. This one look like that is 0.7t, but do you see this is a finish of the integral? And this is our integrate of 0.7. And that's why they put 0.7t here, because this is stuff that finish integral. If you integrate 0.7, it's going to get 0.7t. But this is not, 0.7t is not part of integral. I thought that they did pretty crappy job here when they have a rubric like this. They should just do r of x minus 0.7t between 0 to t. I think that's a right way to do things. I think this is probably very, very confusing for students. Now, since there's only 80 people left on the escalator, So I'm gonna kind of show you what happened on the escalator. Um, exit for screen, exit to the left screen here. So imagine that if you go to subway, right? Let's say in New York, this subway, this escalator, this is going up. There's already people on the line. There's already like maybe like 3 people on it, and we can say that represents those 20 people in the line. And when the train arrived, there's all the people rush into the escalator. But those people are still leaving, right? Same thing, same situation. People leaving. There's people rush in at certain things. So maybe that they come in, and that's why that after 300 seconds, that's become 0. Because after 5 minutes, there was no people line up into the escalator. Because when the train arrived, people line up on escalator, people get on escalator. But after the train leave for 5 minutes, there's no more people on the escalator. Does that make sense? I mean, not no more people on the escalator. There's no people go in the escalator. It's only people go out the escalator. So that's what happened in this situation. You have 20 integration this plus the in out rate. You got 80. Then 80 divided by 0.7. Why? Because there's 80 people there. Nothing comes in. So you are leaving for 0.7 per second. So it'll be 0 people per minute. So you divide it by 80 by 0.7. So that's going to be 114. 114 added to 300. That's the time it's going to be completely nobody there. So that's roughly, I don't know, 7 minutes later after the train arrived. Then there was nobody on the escalator. Does this make sense? Okay. Now, for the last part, those people don't understand is you gotta make sure you understand net rate equal to the in rate minus the out rate. And net rate, you can think about that's a velocity. And this is in velocity minus out velocity, right? So obviously this is gonna be, in this case, this is gonna be R of X, and this is a 0.7. Now, why do you want it to look for the 0? Why do they say R of t minus 0.7 is equal to 0? Because let's graph it. If I graph it like this, and let's just say if I graph it like in the home screen. If I graph this on the calculator, how many of you guys stuck in the straight line at first? Do you stare at this line for like first 30 seconds? Like, what the heck?
Yeah.
Yes? Okay, so that's normal. Because most of you guys didn't pay the attention to the domain. Now, this question I thought was designed very well. I put this question on 2 years ago's test. And they designed really well because when they design, now what happened is you have to learn to adjust the domain to 300 seconds. So I like the 310 because I want to see a little bit to the right of 300. That's with me of a habit. I like to see y-axis as well. I like to see this. So this is what is at the end. Ashton, are you following me so far? This is a net rate equation. So this equivalent to the velocity equation. I'm just trying to tell you the velocity equation is no different than the velocity equation before, the furthest right and furthest left. Now, if I take a picture of this and I'll start shading it, I start shading this is gonna be the things that is leaving, the things that they doing, and I'll shade it in blue is oops, my bad. Blue. It's gonna be here. This is gonna be people more likely to accumulate more people because the velocity is positive. So you're gonna accumulate more distance. Now, do you realize that if you integrate the velocity, right, which is the unit is a meter per second, If you integrate that, you're gonna get meter, amount of meter. Does that make sense? So if you integrate this the rate of leaving because they are negative, then it's gonna be the people that's leaving. Because at first the rate is people per minute. The net rate is people per minute. If you integrate it, it's gonna get people. Is that okay? So it's correlated to every question. If you realize it's a correlated to every question, a lot of time people try to look at this question, I do it this way. The way I look at math question is this question do it this way, and this question look at it this way, and I look at the common ideas. When I study for SAT, I look at the common ideas. What kind of ideas always on there? And I'll study for those ideas rather than study for the question. The question can always change. It becomes a traffic problem, becomes an escalator problem. It doesn't matter. So this is people are leaving. So whatever leaving here, I know this is going to be the min. Why? Because when the rate becomes to the 0, that's when
people start increasing.
Yes, people start increasing. Thank you. Yeah.
It stopped decreasing, which means it's been decreasing to the point where it cannot decrease or will not decrease
Yes.
further.
And then now there's people accumulate into the escalator now. So this the blue part is people start getting on the escalator, but people leaving is not as much because people. That's the constraint, because if you have draw a hole right here, a small hole on this water bottle, it's only leaking like a couple drip at a time. But if I pump in a different rate, if I have more inside, then water's gonna start rising. Does that make sense? So that's the idea. So this is the min, and this is the max. Why?
Because that is the point where it has stopped increasing and it started to decrease.
Right. So the velocity is there's more at this point. This net rate equal to 0. So net rate is equal to 0 is pretty important. When velocity equal to 0, when the particle change direction. Here, if the changing from positive to negative is they stop increasing or they stop decreasing in terms of amount. Is this understandable? And then so then you look at integration. You are look at 20 plus the integration from 0 to, I think the first part is 33 of, R of t minus 0.7. And that's how you get, I think it's a 3.8. 3.8. And then 20 plus integration from 0 to 165 of R of t minus 0.7. I think that's how you get 158. So this is the maximum number. So all they gotta do is change the word. They say what's maximum amount of people that's on the escalator, and when you're gonna say is that happened at 165 and there's 158 people. And what's minimum people on the escalator? You're gonna say it happened at 3.3, and there's 4 people on the escalator. But your table must including what? The endpoints. So I'm gonna express this again. On AP exam, we call it this candidate test, and this is a rubric. The reason why they do this rubric is because math people don't like to read. They like to read tables. They prefer read tables than you give me sentences. So Ian's gonna say, "Oh, that stopped increasing," and Ian's gonna probably write an essay about it. And math people don't want to read the essay. They want this. They want a table. We call it candidate test. Okay, so that table is very important to explain the furthest right, furthest left, right? Is explanation for your absolute max and absolute min. Now, if you realize on your test, the first test question on your test was the banana, right? Like one of the questions is banana. That question did not ask you absolute max and absolute min, but they can ask you absolute max and absolute min. They can say, well, what's the highest banana that's ever on there, right? Or what's the minimum amount of banana that's going to be on the table? They can ask that. Your second question is FTC. That one asks you absolute max and min, because you had to do a table at the end. happened, I think is 5 seconds, and you got 7/2 negative. So this question is repeated throughout different questions. So this is the question that you want to put more emphasis on, and you want to get 2 points here, 2 points there, 2 points there. So totally you get 6 points. So you must know how to do a table. Any question about this part? I'm spending a lot of time on this because I look at the common denominator between all the FRQ. And if I can target a little bit more, I spend whole period talk about it. Hopefully you can get 2 points here, 2 points there, 2 points there, and 6 points on 3 different questions. I prefer that happening. Any question about that? So do you guys understand this question? Ashton, do you understand?
Why is it minus 0.7 and not 0.7t?
Can somebody explain that?
It's after we integrated it, so you add the t after.
Because you kind of find like that specific point at 300, it's like trying to find it throughout the entire graph. So if you incorporate t, I'm pretty sure, right? That's true. I'm sure if you incorporate t, then it's like finding it specifically at 300, but you're trying to find it in the graph. When you integrate it, it's going to go from 0.7 to 0.7t. That way you don't like.
At any given moment in time, it is going to be that with the t affecting it. But this is before we apply the effect of time to the actual thing. So the time is added later. So this is just what it is at the base before time effect.
Okay, let's just say this. If you walk like 0.7 mile per hour, right? If you walk like 0.7 mile per hour. And if you just say, well, how many distance you walk at the first 5 hours, don't you have to integrate 0.7, which is your velocity, and you'll get 0.7t, right? So if I integrate, that just say if let's say if I integrate this 0.7, and let's say between 0 to 5, that's the first 5 hours, then that's gonna be 0.7t between 5 to 0. Right? So that's gonna be 0.7 times 5 minus 0.7 minus times 0. So that's gonna be 3.5 mile, which kind of makes sense. If you walk 0.7 miles per hour, then if I integrate between first 5 hours, that means amount of distance. In this case, is 0.7 person per minute per hours. If I integrate it first 300 seconds, that means amount of people that's leaving at between 0 to 300. So you cannot put t. If I put t, that becomes t squared. And if a t squared, that doesn't make sense, because if a t squared here, then you're gonna walk a lot more. You're gonna have 25 rather than 5. You look like you're still confused.
I mean, I see it and I get that point. I just don't get where it says like r of t minus 0.7 equals 0. Like, what did you do with that r of t?
I integrate them using the calculator. Now the thing here about, are you talking about this one, or are you talking about this one here? This one's really poorly written because this 0.7t is already integrated because dx stopped here.
I'm talking about the equation below that.
RT minus 0.
Oh, RT minus 0.7? Yeah, because you're compared the RT is rate in and 0.7 is a rate out. You want the rate in minus rate out equal to 0 because that's when you start turning around.
And that's what you plug into the calculator?
The calculator is going to plug in, what you're going to do is going to plug in is 20 plus integration from 0 to 33.5 33.013 of r of t minus 0.7 dt. Or you can do this 20 plus 0.33.017 minus r of t. This is 3. R of t minus 0.7 to the t and plug in 33.017. Because this times each other is still going to be the same thing. If you integrate this, it's going to be 0.7 t is all the same. So what happened is they wrote this part bad. They should not say dx right here. They should say t dt, and they should put a 0.7 inside. You're gonna get the same result. You look like you're still confused.
No, I get that. It's,
Now, which part you don't get?
I don't really know.
Claire, maybe you can explain to her. Because for me, like sometimes you listen to me talking.
Velocity is simply how much something wants to move, not how much it is moving.
Yeah, let Claire.
That sign isn't applied to it yet. This pencil, imagine the next split second I drop this pencil. This pencil would be wanting to move down. It would have the velocity of moving down, but it hasn't moved yet.
I think Ian, you're confusing her. I'll let Claire explain to her. That's okay. Danya, do you understand? Can you get it right next time? Will, Emerson? You understand?
You need to do that to get the
I'm
bound.
confused on how you got 33 and 165.
Oh, how do I get it? If I graph the net rate. So this, the net rate, is this minus 0.7.
Yeah, I put that in my calculator. That's what I have in my.
You need to do that to find it.
And you graph
That's
it.
my graph, and I have the right window. It's from 0 to 300.
Yeah,
But I don't.
to find the zeros. Go second, 0,
Oh, we go to 0.
and then go left side of that 0 and the right side of that.
Okay. Okay, I got it.
Okay, and then you're gonna get a second point. Then how you do?
From
How do?
this 0.
Yeah. So here you can do is you can find out how many people are leaving. Second calc integrates
From
between
0 to
0 to 33. Then you should get, see this shading, that means that people are leaving. So it'll be 20 minus this.
20
And
minus
that's
that. So
that way before.
okay. Oh yeah, and then that's the value of the.
Exactly.
And I found that
Okay.
by myself.
Claire, did you explain to her? See, I will probably Claire probably say exact same thing as I say it, and all of a sudden they like because she's white and and Ashton gets it. It's like Ashton's secretly racist.
She brought up a different about what somebody else I was confused about.
Oh, okay. Another word, Claire is smarter than Mr. Ye. That's okay. It's all good. It's all good.
Same question that's better than you. Like we can find yeah, explain the same question, but it's better what you explain.
Okay. Okay. I'm taking enough insult today. First is Claire is better than me. The next thing is Gabby is better than me. That's okay.
I like the Zoom call with Gabby.
Gabby is great.
I did. She was really good at explaining, but at the same time, I felt like I was a 3-year-old. But maybe that's all I need to be explained to.
All right. So I don't have time to go over the other questions, but I'll show you. I'll put an answer. But one day we're gonna go. Each day we're gonna go through one for the next 3 days. So we'll go through one each 3 days. So I'll post the answer all three. And if you think about those questions, if you figure out what is it, we'll figure out together. But right now I'm gonna talk about logarithm. Okay. Log. What is the logarithm? Because later on we're gonna take a logarithm differentiation or integrations. So log logarithm is very, very important. Now, anybody is taking AP Chem here? Raise your hand. Okay. When is the last time you used log?
Exponential decay.
Define P.
Yeah.
To calculate pH. Thank you. How do you calculate pH, Ashton? Oh, you're supposed to know. Okay, let me teach you. Most log is called common log. Now, shh. Now, if I don't write anything here, it doesn't mean there's nothing there. It's like square root. Doesn't mean, so square root, right? Doesn't mean there's no number here. There's an invisible 2. If I don't write any log, what's the invisible what? 10. So you should know that's log base of 10. So that is called common log. Like square root is equal to square root like this. Okay, so that is very, very well known. Now, this is the first category of log. When we introduce you is the common log at very beginning. When you calculate in chemistry is a common log. Second, can I have different kind of base of log? Yes. One of the most common base is what?
2.
E. And that's gonna be natural log. Thank you. If that's an E, it's called Euler's number. And you're gonna be like, what is E? E is equal to 2.718. E is equal to 2.718. And roughly, so E and pi are number are very, very close to each other. E is a big knowledge. In BC right now, we still talk about E. We talk about definition of E. Those of you guys are interested about definition of E is x approach infinity of 1 plus 1 over x to the x is equal to E. Now, that's something that you don't need to know here, but I'm going to give it to you. That's definition of E. Now, third is all other logs. So log common base 3, log base of 4, log of base of 5, etc. So 3 type of log. Common log, natural log, and the thing. Now, those of you guys in chemistry, let me teach you how to find pH. Well, it's called hydrogen ions. Depends on how much hydrogen ion in your water. So, is the concentration of H plus, then deciding how acidic the function. How do you determine that? It's actually negative log base of 10 is equal to pH. Now, those of you guys in chemistry, I'm going to kind of help you review. pH plus POH is what?
14.
Oh, good. You're going to get a 3 in AP Chem now. Huh? You did so bad. Did you pass? You got a 3. See, I told you. I said you got a 3 just by knowing this. Hey, 3 is not bad. 3 is not bad. Okay. So pH plus POH is equal to 14. Now, sometimes I can actually do this without calculator. Let's just say there's a concentration of 0.01 molar of HCl. It's called hydrogen chloride acid. And for those of you guys need to understand, hydrogen chloride acid is 100% dissociation. So it completely dissociate. So that means this one can be also 0.01 molar of H plus. I could be a chemistry teacher.
I have a chemistry test next year.
Times 0.01. Do you know what is the how much a pH of this without using calculator? Do you know what's pH of this?
Let me remember how log works. As far as I can find, it's -2. That doesn't exist.
Ian, what did you say?
far as I can find, it's -2, which doesn't exist.
No, it does exist.
What?
So you think about it, right? Log base of 10 of 0.01 is equal to some type of x. Now remember you draw a heart. So it'd be 10 to the x equal to 0.01. So 10 to the x is equal to 10 to the -2. X equal to -2. But you place the -2 inside. So it'd be -2 times negative is equal to 2. pH is equal to 2.
Okay, because yes, because it's a -2 because it's a reverse exponent, it's moving down, but because it's that and you have a negative in front of a log, you reverse it. Wow, that is incredibly acidic.
pH 2 is not incredibly acidic. I think stomach acid is more acidic than 2.
You realize like 7 is water.
7's water. 2 is about, I would say, like a very strong vinegar. It's not gonna dissolve. It's not gonna dissolve your skin.
No, 7 is water. Higher is basic, lower is more.
I know my chemistry.
Isn't it lower is more acidic?
Yeah, it's no less is more acidic.
Yeah, and vinegar is like a
Vinegar probably like 3 or 4. Oh no, vinegar is yeah, citric acid's about 3. Orange juice about 3 or 4.
Right. You have Waddell.
Okay.
I'm sorry for your loss.
All right. So what I'm trying to say is, I remember in AP Chem, not AP Chem, when I was in college in chemistry class in UF, I remember there was one question that you don't have a calculator, and they say, oh yeah, it's a 0.005 molar of things, and they say, can you calculate the pH is between two values, which is pretty smart because 0.05 is it's between two values. It's between 0.01 to 0.001, and so the pH has between 2 to 3. So that's the way they ask question. I thought it was very creative. Whereas if you're not math-oriented person and without calculator, it's pretty difficult. But anyway, that's that. So that just talk about pH and logarithm. Now, what happened is, you know how to convert from the exponential form to the log form. 2 to the third power equal to 8. So you can draw a sideways heart like this. And then that's going to be log base of 2 of 8 is equal to 3. I don't know if Ollie or Ken teach this. I think they do. Basically, that's how you convert exponential form to log form. You can convert the log form to the sideways heart. It's going to be 2 to the third is equal to 8. So that's a way to solve logarithm problems. And that's going to give you a lot of points on the AP pre-cal, I think. Huh? Yeah. It's pretty dumb. It's like easy. That's like more like, I would say like my Algebra 2 student can take that test. Because now I really wish that I have another person like me teaching Algebra 2 in this school. If it does like this, I think we have a lot more bigger because there's more like knowledge to be like inserted. But I think most of the Algebra 2 teachers just kind of give you a test exactly same as the homework or same as the test. And that's the problem. So do you understand how to do this? Okay, so let's talk about property, log properties. Log property. Now you can replace the log, so you can replace log with natural log. That's okay. So if I ever say log, actually I'm going to use natural log. Natural log of m plus natural log of n equal to natural log of mn. That's the first property. It's called product property of logarithm. Second property is natural log of m minus natural log of n is equal to natural log of m over n. the third property is natural log of n m equal to natural log of m to the n. So this is called power rule for the logarithm. The last one is a very weird. It's called changing base of formula. Changing base formula. N is equal to log base of b of m is equal to natural log of m over natural log of b, or natural log of log of m over log of n. So those are the first four properties that you need to know for logarithm. If you see this, it's very common happening all the time. Yes.
What was the second property called?
Quotient. The first one's product property of log. Second one is quotient property of log, and the other one is power property of log, and the last one is changing base formula. Okay. So with that being said, you know some basic property. For calculus, you need to know how to expand. So how would I expand something like natural log of x squared over y to the third square root of z? How do you expand this to multiple log?
And change the natural log of x squared minus natural.
ln of x squared minus ln of y third square root c.
It's not completely expand yet.
I think that percent d is also a variable.
Thank you for the BC lecture.
Nice, nice. Now there's something else that people usually make mistake. Yes, Ashton? Oh, okay, what do you think is?
Okay, I could be wrong. Is it 2 lsx minus 3 ln y minus 3, sorry, minus 1 half ln z?
Yes, perfect. Good job.
Sorry, what did you say?
Okay, so what happened is I'm gonna do it once. I'm gonna do it slowly. So ln, and there's a people that usually make mistake. I'm gonna talk about that mistake. It's ln of x minus ln of y to the third and the z to the 1/2. This is my first step because it's top minus bottom and it's 2 natural log. Is this okay?
Yeah.
Now I'm gonna do this side here first because this is multiplication. So it's going to be natural log of y to the 3 plus natural log of z to the 1/2. Now, why do parentheses? Because a negative sign is going to distribute both. Most of people make mistake on this sign right here. So this one's going to be 2 ln of x because the power becomes the coefficients. Here it's going to distribute the 3. It's distributing negative signs to be 3 ln of y. And this is going to be minus half ln of z. And this is a proper way to expand something. The problem is people make mistake on this sign because they think this two is multiplying each other, but it's actually dividing by y to the cube and divided by the z to the 1/2. So that's how you do proper expansion. Is this okay? You need to know this because if you do this, it's easier to take a derivative with the natural log. So you need to know how to expand. How much time I have?
2 minutes.
Okay. Okay, so how would I expand this? This gets kind of tricky, right? Wait, have you ever seen a square root inside a square root before?
Because if it's an because it's just an exponent of 1/2, and if you're trying to find an exponential fraction, will that be the constant time y equals 1/2 to the negative 1?
Your homework is gonna be a log worksheet. It's not gonna be calculus yet. Tomorrow we're gonna deal with calculus.
Do that.
Prashant is like.
Wait.
Yeah.
1/4 natural log of x minus 1/2 natural log of y, and then minus 2 natural log of z.
What?
Possibly. I don't know. Ln of square root x over y to the z to the 4 to the 1/2 power. So I'm gonna do that first. And then 1/2
Oh, there's
This-
another one
ln
now?
x to the 1/2 minus ln of y plus ln of z to the 4th. So that's equal to 1/2 to the 1/2 ln of x minus ln of y minus ln of z to the 4th. And then you distribute, so it'll be 1/4 ln of x minus 1/2 ln of y minus 2 ln of z. William, that's already more than you learned the whole year in Mr. Robertson's class. In 5 minutes.
I'm shooting.
Bye.
See, when I said bye, Mr. You never answered.
Because D9 not important. I'm just kidding.
Mr. I'll see you Monday. I won't be here tomorrow.
Oh, tomorrow's important.